Hello everyone, welcome to this SEU-NPTEL online course on space environment and its effects on orbital spacecrafts. So, in this module we are discussing the orbital radiation environment and its effects, and in this regards we discussed two types of radiation, that is the ionizing radiation and the non-ionizing radiation. And in ionizing radiation also we discussed the energy of the particles, radiation particles whose velocity is relativistic. So, we consider both the relativistic the energy consideration as well as the Newtonian, that is the energy consideration. So, in that is the classical using the classical mechanics, we derived the expression for the energy transfer when a charged particle is in the vicinity of a target molecule or atom, what is the how the energy is transferred. So, we defined the term, that is the LET, linear energy transfer, and this is the total ionization dose. The two terms, one is if the T is the energy transfer, then minus dt by dx, where x is in the direction in which the particle the charged particle is moving, and the other is dt minus dt by dm. So, these are the things we considered, and then subsequently we took the cases where the particles are having very high energy, where this classical, that is the Newtonian mechanics we cannot use. So, using those the relativistic approach, we considered the type of radiation, that is the Bremsstrahlung radiation, and we discussed the X-rays, then the gamma rays, and how the X-rays and the gamma rays and the photons they interact with the material, and the effects we considered the photoelectric effect. Then the other effect we considered is the Compton effect, and then the pair production. So, these are the things we discussed, and in the last session we discussed the displacement damage. So, displacement damage we call it is the effect is that is a non-ionizing effect, but it is caused by the ionizing radiation, and we have seen what is the displacement damage. And then also we discussed the total radiation dose. So, total radiation dose, it comes when I consider my energy interaction is an ionizing radiation. The radiation is ionizing. When it is non-ionizing, we call it the displacement damage, and both are the things they gives an indication of what is the total radiation dose. And especially the displacement damage we have seen, that is how the lattice structure is damaged by the displacement or the dislodging of the the atom in the lattice structure, and it gives rise to a vacancy as well as the interstellar atoms, means a atom is entering to a lattice structure, the regular lattice structure. So, with this we will now proceed to the new topic, which is again related to the ionizing type of radiation. This is called the single event effects. So, in single event effects we will discuss is different types, that is the single event offset called the SEU, then single event Latch-up SEL, then single event burnout, the acronym is SEB, and single event gate rupture. So, all these four types we will discuss. So, what is single event effects? So, single event effects, this is a transient, it can be transient or the permanent effects that result from a single or a few quanta of radiation. So, as we have seen the cases like the total the TID, the total ionization dose or the displacement damage, it happens, it gets accumulated and it happens over the time, over the mission, it can be over the the whole the mission life it can happen. But when we are considering the single event effects, it is instantaneous, it It happens, it can be caused by a single particle, very high energy single particle. And one more thing also you have seen, that when we are considering the lower energy radiation, there the energy can be stopped by the target material. There is a range, but we have seen whenever that is using the relativistic approach, this that is the decay of the that is the radiation, the interacting radiation, that is exponential. It is not stopped. So, whenever there is the radiation is the charged particle is having enough energy, high energy, it will not be stopped by the target material. It enters and it creates a few phenomena which we are going to discuss, and the whole this phenomena is called the single event effects, where this damage or this whatever the effect is caused by either a single or a very few quanta of radiation. So, the single event effects are, it is generally caused by two types of space radiation sources, which already we discussed, that is, one is the solar protons, and solar protons it comes from the solar energetic particle, or also it is called the solar particle event or solar proton event, and galactic cosmic rays. So, in these two phenomena, you can have very high energetic radiation particles. It can be in the giga electron volt GeV. So, the occurrence of the single event effects, it is it become more, the likelihood has increased, because these semiconductor devices, especially the integrated circuit, because of this advancement in the technology, we are having very large scale integration in. With this thing, what is happening? We are accommodating the different devices in a very the area is very small. So, like the diodes or the transistors. So, because of that, whatever the critical charge which is required, or the energy of the charge which is required by the incoming particles, that that thing is, that is the critical charge, what is the requirement has got decreased because of this that is the technology advancement is in the integrated circuit technology, where the miniaturization is happening day by day. So, this has caused this effect, especially the single event effects has become the more and more prominent with this, the advancement in the IC technologies. We will see that one by one. So, thus the effects on electronic devices are normally divided into 4 categories that we will be discussing one by one. That already I told you, that is single event offset, then single event latch-up, then single event burnout, and the single event gate rupture. So, we will see one by one how this are what are these terms and how they are different from each other. So, single event offset SEU. So, a single event offset SEU is a type of error that occurs in electronic devices, especially the digital devices or the memory, that is the semiconductor memory or the logic circuits. And this is caused by a single energetic particle. It can be a cosmic ray or a radioactive decay particle striking a sensitive region of the device. We will see that is what is the. So, it can be a memory device, it can be just the gate of a memory device, it can be a MOSFET or a CMOS device. So, this SEU, this is a change of state. Change of state means the bit, it can be the flipment of the bit, 0 can become 1, 1 can become 0. So, that is why it is called the change of state caused by ions or electromagnetic radiation striking a sensitive node in a microelectronic device, and that microelectronic device can be in the microprocessor, or it can be semiconductor memory, or it can be power transistors. The state change is a result of the free charge which is created by the ionization inside or close to an important node of a logic element. It can be a memory bit. So, because of this there is the there is a flip in the bit, And so, because of that, there is a because of this beat change, there can be though it is not permanent, we will see that it is it can be corrected, but temporarily it can malfunction if it is not detected and corrected. And this is the reason, because you can correct that whatever the bit flip, it can be corrected by uploading the command. So, that is why this type of the upset, that is a single band upset, is also called the soft errors, because the device hardware is not damaged here, and the error it can often be corrected by rewriting the data. So, we will just see how it happens in the as I already said, that is the MOSFET, that is metal oxide semiconductor field effect transistor. This is called the MOSFET. So, we will consider a N type. So, you see this is the structure of the typical the N type MOSFET for the gate and the gate, drain and source. So, this constitutes it can be used as an amplifier depending on how it is operated, how the biasing is applied, how the signal conditioning. So, depending on all those things, it can be used as a you can used as an amplifier, it can be used as a switch, so in on and off state. So, on off state means it can be high voltage or the low voltage. So, and thus it can be used as a memory devices. But because of this this is a high energy particle, it has entered through the gate and then it is through that the substrate, and it is. So, what it has done, this path it has become a conducting path, where the free charges are possible to flow. So, because of that, what it has done, whatever the biasing and whatever the depletion region is created, that is getting, it is what is called, that is modified by this energetic particles. Okay. So, because of that it can manifest itself as a transient pulse. So, in transient pulse, when you are using as an analog device, suppose if you are using as an amplifier, so suddenly a spike will come in between because of this current pulse generated by the high energetic particle, or it can be a flip of the beat in the digital logic devices. So, we will see further how the mechanisms. So, we will consider the heavy ions and proton. So, whenever the the heavy ions, so heavy ions again it is the same. So, the here a diode has been considered. So, it is a N type and P type, and in between this is the depletion region. This is the depletion region. Depletion region. So, again it is the same case what we explained just now. So, because of this heavy ion, it has taken a path and it has strike, or it has gone through this this junction, p-n junction. So, creating a conducting path. So, semiconductor, it is mainly it worked by the what is the biasing you are giving, and this the charge carriers are controlled by the biasing. But if this type of a path is created, so that the biasing will not work here. So, a reversed biased junction can act like a forward bias, there can be enough current there, means a state it shows that the state can change, it no more it will work like a switch. So, there can be no permanent current. The second is the second case it shows the it is a energetic protons. So, the protons will interact in differently. So, generally there will be the nuclear reactions, and as a result of the nuclear reactions there will be the recoiled atoms, that is very high energetic atoms, and those atoms can create again the ionization, and it can create a current path. So, here it is because of the nuclear reaction, because of the very high energetic proton passing through the material. Now, we will see that is the galactic cosmic rays, and the galactic cosmic rays it generally it contains the nuclei of the high energy particles. It can be electrons, positrons, neutrons or antineutrons. So, first charge particle, it can be the very high energetic electrons. So, you see it is also creating a path, a current path or the trail of current similar to that happened when we are considering the heavy ions or the protons. And this case again here also it is the proton in GCRs. So, this phenomena is this similar. So, it is getting the recoiled atoms, and those recoiled atoms can create the current paths in the substrate through the depletion region of the p-n junction. Now, we will consider the offset mechanism in a random access memory. So, again here the memory device, this is a NMOS here, and you see there is a energetic particle which has striken the drain, and this will produce an impulse which can cause the upset. So, you can consider this is a memory bit in this circuit which is shown here, and so what it can happen. So, this is the gate, source and drain. So, it can affect the drain here, and because of this there can be a change of the state. So, the switch can be suppose it is in off condition, it can be in the on condition. Of course, this on off thing, because of this is a single event upset, that can be corrected, it is not a permanent one. So, the next that is the event or the phenomena, this is called the single event latch-up. So, now we will try to understand what is latch-up. Is something like a short circuit, and it is not a temporary one, but it is a permanent one. So, single event latch-up or SEL is another type of radiation induced fault that occurs in semiconductor devices, but its severity is more than the single event upset. So, in single event upset, it can flip, or there can be an instantaneous spike in the noise, but that will not appear again, or in the case of memory devices, this can be corrected, this can be reset, that bit can be reset and it can be put into the correct its bit state. So, how this SEL happens? It happens when a high energy particle, it can be again the cosmic ray or heavy ion. Again here we are considering the same, either it is a cosmic ray or, but here the energy, that is that will be definitely the difference in the energy, and what is the the type of the material you are using, that will depend on that. So, the phenomena is similar, but its effect is different. So, here a cosmic ray or heavy ion, when it strikes a sensitive part of an integrated circuit, and that can trigger a parasitic structure, that we will see what is that parasitic structure inside the chip, and causing a low impedance path between the power and the ground. So, here what is happening, it is something like a short circuit, very low impedance path is created between the power and the ground, and that when this happens, the semiconductor the devices, it will not, or the memory device, it will not work like a the way it should work. It should not be, it will not be controlled the way the semiconductor devices are controlled or they are operated. So, because of this, the triggering of the parasitic structure inside the chip, which is causing a low impedance path. So, this will create a very high current condition, and high current condition means it is something like a electrical short circuit, and this can persist until the device is powered down or reset. So, here it is not this error created by single event latch-up, it is a hard error. So, it is not a soft error. Hard error means if this happens, you cannot correct it. So, unlike the single event offset, the single event latch-up can cause permanent damage if the high current is not quickly stopped, because it can lead to overheating. So, whenever the current is passing through the device, it will be heated, and because of that overheating, the device will fail. So, most of the modern CMOS devices, we will see in the next slide, the CMOS device where the PMOS and NMOS are used in tandem. So, because of that construction of the CMOS device, there are the parasitic transistors, embedded unintentionally within their structure, and when the particle strike, they creates enough charge and it can turn these parasitic transistors. So, it can the bias, it can forward bias the parasitic transistors, creating a feedback loop that sustains very high current, and this state is called latch-up. Latch-up means there is the high current, and it does not latch because it does not stop it by itself, and this excessive current can damage the chip or even cause permanent destruction if power is not cut off quickly, and this can lead to system crashes, then degraded reliability or the catastrophic failure in critical applications. It can be the spacecraft, it can be anything in the aviation or the military hardware. So, we will just whatever I just said, we will show it with this is a typical the schematic or the circuit diagram of the CMOS device, where this is the NMOS and this is the PMOS, and you see these are the parasitic NPN and PNP. So, this is NPN and this is PNP, parasitic transistors formed, and this is the N well, where it is the lightly doped N type material, and so this is the intrinsic bipolar junction transistors or the the parasitic, these are the parasitic bipolar junction transistor in the CMOS. The CMOS technology used in as a memory devices in other digital or the electronic systems. So, what happens whenever the particle strike? So, it can result in the creation of electron and hole pairs. So, you can see this it is creating the electron and hole pairs which are free to move in the substrate. It can be in this substrate or in the well, it can be here. So, you see it is this path. It is going through the this N type well and going to the P type substrate. So, because of this added charge, it can locally debias the well or the substrate, and thus it can forward bias the parasitic devices, where it is a PNP and NPN type the transistors, and thus it is forward biasing the parasitic devices based to emitter junctions, and which will allow the current to flow between the devices, the collector and the emitter terminals. And if the injected charge is large enough and the device bipolar amplification of the thyristor. So, basically this forms a thyristor configuration, PNPN type of the configuration, and by the two parasitic bipolar transistors is greater than unity. If the amplification factor is greater than unity, then it will then the forward feedback loop created by the two devices will cause the total currents between the supply to the ground, supply rails, and it will increase very rapidly. So, you see this is the thyristor formed by these two parasitic transistors PNP and NPN, and because of this these devices can remain latched even after the when the original particle strike has got it has subsidized, still also this thing will it will continue, and it can give rise to the permanent the damage of the device. Now, this second or the third type of the single event effects, it is called the single event burnout. So, by name you can understand that here it is a physical damage. The type of the events you consider SEC, the first two types, there is no physical damage. It is can be the damage in the atomic level, but here burnout means there is a physical damage. So, single event burnout is a very serious and destructive radiation induced failure that can occur. It can occur in power semiconductor devices, especially the power MOSFETs, and when they are exposed to energetic particles like cosmic rays or the heavy ions. So, SEB happens when a very high energy particle strike induces a localized very high current in a power device that leads to catastrophic device failure. And unlike the case of the single event upset or single event latch-up, this type of event, that is single event burnout, it causes permanent physical damage to the device. Essentially it is called the burning it out, and the device is irreparably damaged. It is a damaged device, that is why it is called the burnout. So, when a high energy particle penetrates the power MOSFET, it can create a transient high current in the device drain to source path, which causes this the burnout. And this transient current can escalate quickly due to the device internal structure and high voltage conditions. And the resulting thermal and electrical stress cause the device to physically break down, often by the melting, it can be melting or creating permanent shorts. So, SEB it usually occurs under high voltage bias condition where the device is stressed. So, this is also, if I say the SEB is also, it is a hard error. Then the fourth one is single event gate rupture, SEGR. So, here since you are calling the gate, so it is basically the gate of the semiconductor, the MOSFET or the CMOS devices. So, single event gate rupture or SEGR is another type of destructive radiation induced failure mode that affects the semiconductor devices, especially the power MOSFETs and other devices with thin gate oxides. So, the metal in between the metal and the semiconductor, the thin layer of the metal oxides are used. So, that gets the ruptured. So, that is why it is called a single event gate rupture. So, this single event gate rupture, it occurs when a high energy particle such as heavy ion, it strikes the gate oxide region of the MOSFET or similar device and causes localized, this is important, it causes localized dielectric breakdown. So, this localized dielectric breakdown we are calling it the rupture of the thin insulating layer between the gate and the underlying semiconductor, that we have seen how it is there in our that is the MOSFET or the CMOS. So, this breakdown it creates a permanent short circuit leakage path between the gate and the channel or substrate. So, this channel is there just below that the oxide the metal oxide layer, this is the channel which is which is controlled, the current that is controlled by the gate voltage. So, that it get ruptured. So, as a result of this you get a the irreversible damage. Okay. And this particular strike that injects a sudden and high amount of charge into the gate oxide, and this induces an electric field spike across the thin oxide layer, and if the field exceeds the breakdown strength of the oxide, it causes a physical rupture or the damage of the gate oxide. So, with this I will conclude it here. So, we described what is a particular very important type of ionizing radiation effect, that is the single event effect and its different types. And in the next session we will now discuss how all these effects, whatever we consider, whether it is a displacement damage or this type of single event effects, how it affects the operation or the performance of the spacecraft. Thank you very much.